In this example, we're looking at determining the moment created by a force about a specified axis. Up to this point, we have looked at determining the moment created by a force on the x, y, and z. So in this case, we've got a force acting on this pipe system, and instead of the x, y, and z, we want to find out what moment is it producing along the axis of O to A. Okay, so now we've got to determine that, and it's not that hard. And what we need to use is this equation here. This equation is for the moment about a specified axis. So we have in here the moment is equal to r cross f, and r is the moment arm distance from the location that we want to know, in the point of interest, cross with the force, okay, which we know that, we're given that. And then it's going to be a dot product with the unit vector of the axis that we're trying to determine. So in this case, r can be from any location on that line of axis, because that's our point of interest. So it can be from O or A. And for interests of simplifying this, we can add letters. So don't be afraid to add letters. So I'm going to add B to the location of where we know that point of action of that force is on there. So that's our only point that we know on the line of action on that force. And so R can be determined from, again, O to B or from A to B. And if we look at this, probably the easiest one will be from A to B. All right, now the unit vector is for the axis from O to A, and that's pretty straightforward. We've done that before. Again, this is the unit vector, okay? It has a magnitude of 1 on here. So let's go ahead and solve for this. So that's what I want you to try to do. So go ahead, you know what R is. Again, we're going from A to B, okay? And again, that's not the unit vector, that's the position vector from A to B. And then the force is given right here as 80I minus 40J and minus 120K newtons. So you got that. And now all you have to do is figure out the unit vector from O to A. So go ahead and pause the video, go ahead and perform those calculations. But first, perform the calculations for the moment and the unit vector, and then we'll look at that. All right, so let's do the first one here. And we have the force, which is given. Position vector from A to B is going to be minus 0.3I plus 0J plus 0K, okay? Because it's just going along that x-axis. So that is much easier than going from O to B. All right, so then we're going to do the cross product of that. Okay, again, make sure you got R crossed F and don't switch them. IJK, and then this results in 0I minus 36J plus 12K Newton meters. All right. Now the unit vector from O to A is going to be, we have the 0.8 along my y-axis, we have nothing along my x, and we go up 0.6. Okay, so that, if we do Pythagorean's theorem, gives us a total length of 1, okay? And so this unit vector, RO, with a little hat on it, O to A, is going to be 0. I like to make sure I keep my zeros when I do this, even if it drops out, plus 0.8 J plus 0.6K, all right? So let's go ahead and now do the dot product of what we got here is our moment dotted with this. Okay, so go ahead and pause the video and go ahead and do the dot product for that. All right, the dot product of the moment we found here, which is right here, dotted with the position vector here, yields a magnitude of the moment of minus 21.6 Newton meters about the OA axis.